In this video, we'll be working through the question you see on the screen from the 2023 Ordinary Level Maths Leaving Cert. I recommend you try the question before watching, and if you get stuck anywhere, feel free to ask for help in the comments. I will do my best to get back to you. Check out my channel for a playlist with all the other questions. This is question 9 from paper 2, and this question is going to be mostly about statistics. The first part of this question, part A, revolves around students asking this question in their school. They ask, how often do you read? Now it tells us a little there. It says on Monday morning they asked 200 students who came into their school how long on average they read for. Now, sort of skipping ahead to what's going to be part 3, and what's nearly always asked in these exams is what could go wrong in this sort of question. And I already see something there. They're only asking the students that came into school that day. What about students who regularly miss school? And we'll talk about that on part 3. So they've asked these students how often they read, and they got these answers. So if a student said they read for 22 minutes, they go into this bucket here from 0 to 30 minutes. If they said they read for 128 minutes, they go into this bucket here, and so on. And this is what they found. So they're going to ask us a couple of questions. The first question is, work out the maximum number of students in this sample who on average could have read more than 90 minutes per day. A lot of confusing English words there. I'm sorry if English is not your first language. That's probably going to be a hard question to answer. All they're saying is, what's the maximum number of students that read more than 100 minutes a day? So, these 16 students, none of them read more than 100 minutes. None of these, none of these. All of these do. All of these do. It's this one here that's the confusing part. They didn't say how many probably does it. They didn't say what's the minimum number. They just said what's the maximum. So, for all we know, every single one of these read for 119 minutes. Every one of these could have read more than 100 minutes. So I'm going to count all of these, guys. I'm going to say 59 read more than 100 minutes. Plus these 18 here. Plus this 10 here. Now the minimum number that could have read would have been none of these. But they didn't ask that. They asked the maximum. So we add these 3 numbers together and we get 87. So the maximum number of students that could have read more than 100 minutes is 87. Okay, on to part 2. Part 2, they say estimate the mean time spent reading by the 200 students as accurately as possible. Okay, I don't actually like this question, which I'll explain why now in a moment. But first of all, let me try and answer it as they want. The median. You need to ask yourself, what is the median? So the median is the middle student if you line them all in a row. So the person who reads the least, and then the person who reads a little more and a little more, all the way up to the person who reads the most. If you line them up, and you could draw this something like this. The person only reads a small bit, next bit, and so on. It would look like a line like this. The median is the middle person. So the first person, the 200 person, the median is the middle person. So that's what we're looking for here. There's 200 total students. So who's in the middle? Your first thought should be number 100. That's close enough really for this question. But it's not quite right. So when I'm ever dealing with medians, I always think of 2 simple cases. 1, 2, 3, and 4. 4 people. Who's the middle? Well, the middle is actually 2 and 3, and then I think 1, 2, 3, 4, 5. Who's the middle? The middle is 3. When it's an odd number, the middle is easy. When it's an even number, like 200 is, the middle is a little harder. Now, again, this isn't actually that important for this question, but still, it's what you should be thinking when they say median. So who's the middle of 100 people? 1, 2, ... 199, 200. The middle, our guess would have been 100, but this should tell you it's actually 100 and the next guy, 101. ... So these are the people we're looking for. Now, in this question, they're the same people. They're both in the same bucket. But we're looking for the 100th person and the 101st person. And again, for this question, just the 100 will do. You're not going to lose any marks for doing this. Okay, so who's the 100th person in this group? Here's the bottom 16. They're out of it. The next 35, add those together. What do we get there? 51. Bottom 51, they're out of it. The next 62, that gets us all the way up to, have I got the number there? Let's see, 51 plus 62 is 113. This gets us all the way up to 113 and starts us at 51. This group here, 60 to 90, they are from the 51st person to the 113th person. So the middle person is in this group. And that's mostly what the exam wants. You'll get a lot of marks by just writing down 60 to 90. The median is definitely in here. The median is in here somewhere. Now here's where I don't like this question. They said as accurately as possible. To do this question accurately, it's well beyond the ordinary level. So I checked the answer, the exam's answers, and they said they will accept any answer in this group. So any answer, like a good guess would be the middle, 75. That's fine. Any answer in that group, because really you don't know how these are distributed. So all we know is the middle is in here somewhere. So any number in this is okay for them. Just to show you a bit more accurately, I would expect the students in here to look roughly like this, starting at 60, going up to 90, roughly like this. If it's from 51 to 113, well then the person I'm looking for is somewhere at the end of this group. So the real answer is probably, let me think, I think I did it somewhere. Oh, that's right, I've done this end. Anyway, the real answer is probably something like 84. Somewhere in that group, or 84 point something is probably the real answer. Anyway, I don't like this question. I think it's a little too difficult for ordinary level students to do what they asked, to get it as accurately as possible. But again, checking their answer, they really only wanted you to guess any number between these two. Okay, let me, well actually I don't need to clean this off to do part 3, because I'm not going to write anything. Part 3 simply asks us to explain why the method of choosing the students for this survey could limit the validity of the conclusions. Again, that's hard English, but all it's saying is what could go wrong. And they ask this pretty much every exam. They like to ask this. This is an important thing to ask. What could go wrong here? And I think I said one or two things, but one thing could go wrong is they only asked the students that came into school. What if a lot of students skip school? Maybe some students were sick. The sick students probably wouldn't have mattered because they should be the same as the students that were in. But students that regularly miss school, maybe they read less, or maybe they read more. We don't know, so that should throw the answer off. They asked, like, who did this survey? Maybe it was 10 people did this survey. Maybe they just asked their friends first. Like, if it was 10 girls did this survey, maybe they only asked other girls in their school. Or if it was 10 boys that did it, maybe they only asked other boys that were in the school. Things like that could bias the solution. You can probably imagine 10 other answers, and any of those answers are okay. The examiner just wants you to think of something that could go wrong and recognize that things can, in every survey, go wrong. So that's all they want you to do there. Okay, on to part 4. In part 4, they ask us to draw a graph to represent this data. Now, the hard bit of here is they didn't tell us what type of graph to do. So you're going to have to do something that students all hate doing. You're going to have to use your imagination. You're going to have to think what is the best thing to do here. And honestly, there's actually a good few answers to this. 3 I can think of will be a histogram, which I'll do carefully, a bar chart, which I'll just do quickly, and a pie chart, which again I'll just do quickly. A histogram is probably the most common way to do this one. So for a histogram, I would put on the bottom axis these numbers here going from 0 up to 180. So let me just do that here. Again, you'll have to use a ruler. The exam paper has a ruled paper, but you should use a ruler and carefully use the boxes that on the page provided. For me, I'll just have to do it quite roughly. 120, 150 and 180. And then going up the side, I need to go up as high as 60, around 60 I need. So let's just put in 6 of them. 1, 2, 3, 4, 5, 6. So that's 10, 30, like 40, 60, so on. So I just want to draw a histogram of this. This should be very common for you guys to do. You should be practicing this regularly. It always comes up in exam, things like this. So the first guy from 0 to 30 goes up to 16. So I just put in a rectangle like that. From 0 to 60 goes to 35. So again, mine's not going to be very accurate. I'm doing it on a whiteboard. You guys should be able to do a lot better than me. Going to 62. Next guy is to 59. Next guy is 18. Where's that? All the way down here. And the next one is 10, somewhere here. So you should get something like that. That will get you full marks. You're done if you've picked histogram. But you could also have done other things. You could have got, instead of 0 to 30, you could have maybe just gone 15, the average, 45, and so on out. And you could have put pretty much the same thing. A bar chart would look something like this. Pretty much like very similar shape. That'd be the difference between a bar chart and what you see there. Again, you get full marks for this if you did it carefully. Made sure your heights were all correct. The pie chart, again, you get full marks. It's just a lot harder to do. There's 200 total people here. So you need to get a percentage, 16 over 200, and change that percentage into a degree. So find out what percent is 16 out of 200. It's 8%. Find out how many degrees in a circle is 8%. So 8% multiplied by 365. I don't know, maybe about 18 degrees or something. So you get something like that. Again, do the same for 35. You get something bigger. 2 big guys, you get 2 big segments there. 18, something like that. And 10. Okay, mine doesn't look good there. Again, you have to be careful on all your degrees here, but you get full marks. I would advise against this one just because it's harder to do. Of course, they might ask you to make a pie chart. Anyway, this is how you do this. One thing to say about this guy. The reason this is the best way, actually this is similar, because you get to see the shape. And in nature, in people, in statistics, this shape comes all the time. The normal distribution. Some people read very little, some people read a lot, most are average. And that shows up everywhere. The height of you, some people are tall, some people are short, most are average. Like anything you could think of is probably like this. Some are poor, some are rich. Although when you get into economics, maybe more are poor than rich, or maybe sometimes more rich than poor, depending on what school you're in, I guess. Yeah, okay, so you get to see the shape. In this case, you don't really get to see that. So the histograms, I would say, a lot better for this bit of data. Okay, that was too much waffling. You already got full marks for drawing this. Let me clean it off and we'll do part B. Okay, in part B, we have a random sample of 500 students from Cork that took a statistics test. 61 of them scored a rating of excellent out of the 500. So part 1 simply asks us to work out the percentage of students in the sample that was given a rating of excellent. So this is very common to do. We're just getting a percentage. 61 out of 500 will come out as, let me check my notes, as 0.122. And again, they want that as percentage, so we just multiply by 100, 12.2 percentage. So they're the same number, same thing. Okay, that's it. That's part 1 done. Part 2. Part 2, show that the margin of error for this sample is 4.5%, correct to 1 decimal place. Okay, so this is a lot harder. A lot of students will just be lost here. It's something you just simply have to have learned from reading your book, from listening to your teacher. You have to remember what the margin of error is. It comes up in most exams, so it is worth remembering. Your tables book isn't that much use here because this is made for all students in Ireland, including college students. And statistics gets a little harder in college, and the ordinary level students is simplified a little. So in the ordinary level, the margin for error you'll find error in the book there. It's somewhat similar. But the margin of error that you're asked to remember is simply 1 divided by square root of n. So you're just asked to remember this. If you want to know the error in a sample, you need to remember this. N is how many people were in the sample. And this is quite useful because in real life, when you're reading the paper or watching clicking an article from a website and it tells you, we did a survey of 10 people, you can find what's the margin of error for that. It's massive. Did a survey of 1,000 people, what's the margin of error? It's actually a lot smaller. And for 500, 1 over the square root of 500 will equal 44721 and so on. Multiply up, turn that into a percentage, we get 4.4721, so on, percentage, and round that off to 1 decimal place, we get 4.5%, just as they expect us to. So any answer we get, it has a margin of error of this, again, as far as ordinary level is concerned. So the answer we got up here, 12.2%, that was just our best guess. It's actually going to be off by this much, plus or minus this much. And that brings us on to part 3. In part 3, it says, in general, students get 10% of students get excellent. So basically, they ask you, what exactly do they ask you here? To use your answers in part 1 and 2 to test that claim. Or sorry, to test the claim that students from Cork are better than not. Yeah, pretty much. Because you see this all the time. A newspaper or again an article online will say, we tested students in Cork and they're smarter than average. Or they might say, students in Cork are failing, they're lower than average. This happens nearly everywhere online, and it's nearly always wrong for the reason I'm about to show you. What this says up here isn't that students 12.2% of students get excellent. That's what it looked like when we did part 1. But from part 2, what it really means is students got 12.2% minus 4.5, which is 7.7%, or 12.2 plus 4.5. Sorry, when I said they got it, let me change what I said here in a second. Let me just add this first. It's 16.7. Okay, what we found was students got 12.2%. That was just our best guess. With this margin of error, what we're saying is really the answer is somewhere between, we're confident, we're 95% confident, which is why they mentioned 5%, 5% level of significance. We're 95% confident that the answer is between these two numbers. And that means students from Cork are average. We expected 10%. Well, yeah, 10% is in this. They're not smarter. Or maybe we think, maybe they're smarter. We should do more tests. But no, we're not confident. We're only confident they're between these two numbers. So the answer to the question, calculations, we do pretty much what I've done there. Conclusion is students from Cork are normal. They're within the normal range. And the reason, because 10% is between these two numbers. That's simply what they want you to say there. I'm sorry, I probably didn't explain that the best, because honestly statistics isn't really my favourite. So and the statistics I do know are often from college level. And anyway, I hope I helped out, and if I can help out more by you, if you ask a question in the comments, I'll try to help out more by clarifying anything here. But until next time, have a great day.